Okay, well, problem number 68, which is x to the fourth minus 81 equals 0. That 4 suggests that there's 4 roots, 4 zeros. This is the difference of two perfect squares. This is the first term is a perfect square, x squared times x squared, and of course 81 is 9 times 9. So I can factor this as x squared minus 9 and x squared plus 9 equals 0. And then I can factor it further. I can factor the first parenthesis into x minus 3, x plus 3. The second parenthesis, I cannot factor the sum of two perfect squares. I can factor the difference of two perfect squares, but not the sum. So this third parenthesis, I cannot factor. So my solutions are 3, negative 3. And for the other two solutions, x squared plus 9 equals 0. Subtract 9 from each side and square root. And can we take the square root of a negative number? Not yet. Not yet. And it's not a real number. So this solution here, even though I can get two solutions, because we're going to learn how to take square roots of negatives, they're actually complex numbers, but they're not real numbers. So the only real solutions are 3 and negative 3, and those are the two places where it crosses the x-axis. All right? That was 66, okay. All right. So that was actually problem number 66.
So I have,
Sure, which question?
so there's only going to be 2 solutions.
There are actually 4 solutions,
Couldn't you
but
put,
2 real solutions.
okay, because my solutions were negative 3 and then 3 and then I put plus or minus 3.
Plus or minus 3 is the same thing. That's
Yeah,
plus,
that's what, but because I was trying to solve for the x squared plus 9 to the solution.
and you can't do it right now. Okay? Later on in this chapter, we're going to talk about imaginary numbers. Right? And we're taking, they're actually complex numbers, and we're taking the square roots of negatives. We'll talk about that later. All right. Is there any other questions on the homework that we had last night? Yes. Okay. 94. Let's try 95 first. 95 says factor x to the 2n minus 1. Is that correct? Yeah. All right, so this is actually the difference of two perfect squares. We have x to the n times x to the n gives you x to the 2n. And then, of course, 1 times 1 is 1. So it's the difference of two squares. It factors as x to the n minus 1 times x to the n plus 1. When I multiply x to the n times x to the n, what do you do with the exponents? Add them. That's where I get x to the 2n. And then we have negative 1 times a positive 1 gives me the negative 1. Outside, inside terms are going to cancel. For the next problem, 96, we have x to the 2n. Is it plus or minus? Minus x to the n plus 1. And when we factor, minus 2x to the n, that's correct, yeah. All right, so when I factor that, it's going to be x to the n minus 1 times x to the n minus 1. Or x to the n minus 1 quantity squared. So let's check that out. X to the n times x to the n is x to the 2n. X to the n times negative 1 is negative x to the n. Negative 1 times x to the n is another negative x to the n. That's where I get the negative 2x to the n. And negative 1 times negative 1 is plus 1. Okay? And now I'm going to do 94. And I'll pause it. All right, this is problem 99. We know the formula for the area of a circle. A equals pi r squared. I can't say it. And they give the area. If the area of the circle, well, first of all, they say if the radius were increased by 4, then the area would be 100 pi. Find r. So we can divide both sides by pi. The result is going to be 100 equals r plus 4 quantity squared. We're looking for the radius for r. We will use FOIL to square this binomial, which is r squared plus 8r plus 16. And remember we talked about when squaring a binomial, you square the first term, multiply the two together and double it, that's how we get the 8r, and square the last term to get 16. Set the equation equal to 0 by subtracting 100 from each side. And factor. We have r, and we have 14 and 6. We need a positive 14 and a negative 6. My solutions are a negative 14 and a positive 6, but the radius cannot equal a negative number, so we have an extraneous solution. And so the radius is 6, and that's what we're looking for. So the radius is 6 centimeters. Question?
And that one, couldn't you square root when you're up at the first step? 100 equals r plus 4 quantity squared. Could you square root both sides and subtract 4?
Yes, that might be easier. If we had 100, or from this right here, plus or minus 10 equals r plus 4, and subtract 4. So positive 10 minus 4 give you 6. Negative 10 minus 4 is negative 14, which we know we can't use. But since we're factoring things, I think this is probably what we had in mind for this. But certainly your way would a lot easier.
Oh, so you just
Okay. Any other questions? We had 98. Was that about the triangle?
Yeah.
Okay. Could you read the information on the triangle?
The altitude of the triangle is 5 centimeters shorter than the base.
Okay.
The area of the triangle
Is 5 less than the base?
yeah, 5 shorter than the base.
Area of the triangle is 1/2 the base times the height. And the height is the same as the altitude. And they're given the area of this triangle as being 12 is equal to 1/2 the base, which is b, times the height, or the altitude, which is b minus 5. Multiplying both sides of the equation by 2, the result is 24 equals b times b minus 5. 24 equals b squared minus 5b. setting the equation equal to 0 by subtracting 24 from each side, and factoring. We have b minus 8 and b plus 3. My solution is 8 for the base, or negative 3. And the base cannot equal a negative. So the base is 8. The altitude, 8 minus 5. Altitude is 3. Okay, that was number 98. I think 99, that other triangle one, is done very similar. All right, section 5.4. Completing the square. In the lesson that we had 2 days ago, 5.2, we were solving problems like x plus 3 quantity squared equals 15. And we had said, do not multiply this out, don't use FOIL. And all we had to do at these two would be to take the square root of both sides. So we get x plus 3, bless you, equals plus or minus the square root of 15, right? And subtracting 3 from each side, negative 3 plus or minus the square root of 15. So if we could get problems to look like that, they'd be easy to solve, wouldn't you agree?
Yes.
When you have an equation that looks like just by your experience now with factoring, do you think that that equation will factor? Does that look like it will factor, yes or no? No. But it doesn't mean that there's not a solution to that. Factoring is the easiest way. But what I want to do is I want to complete the square so it will look like the problem over here on the left. I'm going to add 4 and put the constant, put 4 over on the other side, leaving room. Can you think of a number that I could add to x squared plus 12x so that I could factor this way? Yes. Adding 6 where? Here?
Yeah, plus 36 there.
Plus 36.
Yes,
Okay, and how'd you come up with that?
because 6 and 6 make 12, so that the perfect square would be 36.
Okay, and that's correct. And what you want to do here, and I'll give you something to go by. Step 1, take 1/2 of the b term. Remember, the coefficient of the x squared term is your a. Then the coefficient of the x term is b, which would be 12. So we're going to take half of 12. And then step 2, we're going to square that number. And when you take half of 12, you get 6. Square, you get 36. And then what we're going to do in step 3 is we're going to add it to both sides of the equation. Which kind of makes sense. If I add 36 to the left side of the equation, I'm going to add 36 to the right side. Keep our equation balanced. And the reason we do this, the reason we complete the square is so I can factor this now. Let's factor the left-hand side as x plus 6 quantity squared. And over on the right-hand side, 4 plus 36 is 40. And now I can solve it like I solved this first problem, this example. I can solve it by taking the square root of both sides of the equation, plus or minus, and then subtracting 6. So we have negative 6 plus or minus square root of 40. Can I simplify that a little bit? The square root of 40 is the square root of 4 times 10. And the square root of 4 is 2. And you've got the square root of 10 left over inside. We've done that before. And that's called completing the square. So we do have solutions. Yes, question?
So can you just leave the answer as negative 6 plus 2 minus 2?
Yes, and that's an exact answer. And this is all really that I'm interested in, is the exact answer. The book may say, find the decimal values and round it to the nearest hundredth or something like that. You could put that in your calculator, negative 6 plus 2 square root of 10, and then negative 6 minus 2 square root of 10. Okay, so that's one example. I'll give you about 3. The next example we can readily see that x squared minus 7x plus 1 doesn't factor. So we're going to solve that by completing the square. Out of x squared minus 7x, I'm going to leave a little room, and I'm going to subtract 1 from each side. Okay. To complete the square, step 1. Take half of the b term, half of 7. I'd like you to use fractions. Half of 7 is 7 halves. And because this is a minus, I'm going to make a minus inside the parenthesis. When you take half of the b term, that's what goes inside your parenthesis, and we square it. So the left side is kind of taken care of already. Well, we take half of the b term, and then we have to square it. 7 halves squared would be 49 over 4. 7 halves times 7 halves is 49 over 4. And I'm going to add that to both sides of the equation. And if you don't like working with fractions, we know how to put this into our calculator. You're going to get a decimal value and then change it back over to fractions. And we all know how to do that. Or, if you like working with fractions, this is negative 4 over 4 plus 49 over 4 will give you 45 over 4. Negative 1 is negative 4 over 4, so we have a common denominator. And now we can square root both sides. X minus 7 halves is equal to plus or minus the square root of 45 over the square root of 4, which is 2. And add 7 halves to both sides. 45. 9 times 5. Square root of 9 is 3. And that's your final answer. Yes?
What happened to the 45 over 4? Why isn't that under the square root?
If you recall, if we take the square root of both sides of the equation, we're going to take the square root of the right-hand side, we're going to take the square root of that, and it is the square root of 45, actually plus or minus the square root of 45 over 4.
It would be 45 over 2.
Right.
Gotcha.
Because it'd be the square root of 45 over the square root of 4, which is 2. Okay? All right. One more example. One downfall of using this method. If I had some function, f of x equals 2x squared plus 13x minus 5, and says find the roots. Remember, find the roots, find the zeros, find the solution, find the x-intercept. It's all the same. I want to find the zeros. So I want to find out 2x squared plus 13x minus 5. Where does that equal 0? But when you complete the square, your coefficient, A, your leading coefficient, has to be 1, not 2. So in order to find the zeros, I need to divide everything, every term, by 2. So here I have x squared plus 13 halves x minus 5 halves, and 0 divided by 2 is still 0. Add the 5 halves to both sides. And now let's complete the square. What is half of 13 halves? 13 fourths. Half of 13 over 2 is 13 over 4. You double the denominator. Half of 13 halves is 13 fourths. You can put that right in the parentheses. And then we square it. 13 fourths squared is 169 over 16. And that's what I'm going to add to both sides of the equation. So all that's left to do is adding 5 halves plus 169 over 16. 5 halves multiplied by 8 over 8. So we get 40 over 16. 40 over 16 plus 169 over 16 gives me 209 over 16. Okay, your calculator can handle it if you don't like fractions, but I think fractions will get you there a little bit quicker. Square root both sides. We have plus or minus the square root of 209 over the square root of 16, which is 4. And finally, subtracting 13 fourths from each side gives us negative 13 fourths plus or minus the square root of 209 over 4. Okay? All right, so your homework. We've only covered a portion of this chapter. I'm going to finish up the rest of it on Monday. But what I'd like you to have done before then is on page 304. Just 12 through 36, the even problems.